Now let's begin with the section 3 of the chapter 7. We'll talk about the vectors. So by now, we have been dealing two types of the quantities. And the first type, for example, we have the length, say 2.5 inches. We have the area, say 10 square feet, right? And we have the value, say 1.5 cube meter. Okay, so all these quantities just involves one magnitude. Okay, just involves the magnitude. Only the magnitude. So this magnitude is, okay, a number followed by a unit, right? So that number, say 2.5 and the 10 and the 1.5, these real numbers are called the scalars. Okay, so those real numbers, they are called the scalars. So this is the first type of the quantities we have been dealing with. Then we have another type of the quantities. For example, speed. Say we have the 10 miles per hour. And we have the acceleration, say 9 meter per second square. Or we may have the force, say 100 pounds. And all these quantities involve not only the magnitude, but also the direction. Okay, so they involve the magnitude and the direction. So actually, they are called the vector quantities. So they are the vector quantities. So graphically, we use a directed line segment to denote a vector. So vector, this is just a directed line segment. For example, when we have the vector like this, so we have the initial point of this vector, and then we have the end point. Let me use A for this initial point. So this guy here, this is initial point, and then this P is the terminal point. And the notation for this vector is the vector AB. So we use an arrow above these two letters to indicate this vector. Okay, this is a notation for this vector. And sometimes we may just use the letter for this initial point and then with one arrow over it to indicate a vector. So this is the notation of the vector. And you need to watch out the vector AB, this guy, is different the vector BA. So actually, in the vector AB, A is initial point and B is the terminal point. And in the vector BA, B is initial point and A is the terminal point. So they have the different direction, although they have the same length, right? This length is called the magnitude of this vector. So we use the symbol to indicate the length or say the magnitude of a vector AB. Okay, so this is the magnitude. Or say the length of the vector AB. And when two vectors are same, so two vectors are same are equal to each other if and only if they have the same length, same magnitude, and the same direction. For example, you have the vector A, and then you also have the vector B. So right now, this vector A and vector B are equal to each other because they have the same length and the same direction, although they have the different position. So the position of the vector does not matter. And we have a special vector, it's called the zero vector. And the notation for the zero vector is an arrow over the zero. So this is zero vector. And this vector is kind of special because it has no direction, no magnitude. So this guy has no direction and no magnitude. But you need to watch out. Zero vector is different from the number zero. Okay, so this guy, zero vector is different from the number zero. So you may have another vector which has the same length as the vector A. For example, you have the vector C. And this vector C has the same length as the vector A, but vector C is not equal to vector A because they have the different direction. Okay, so in order to have the two same vectors, you must have the same magnitude and the same direction for them. Now let's talk about the scalar multiplication and addition for vectors.